Hi guys, welcome back. So we've got one more little bit of the second half of chapter 8 to talk about today. There's one more method to solving these quadratic equations, and that is the quadratic formula. This is coming from section 8.9 in the textbook, and we are going to talk about the entire section. So we're not only going to talk about the quadratic formula, but we're going to talk about this thing called the discriminant. I'm sure none of these words make any sense to you right now. But I've said this pretty much every single time, you know? The first thing we talked about was solving quadratic equations by factoring, and we said that not every single polynomial can be factored. We saw last time completing the square, and we talked a little bit about how certain situations when completing the square might not be, realistic. It might be pretty difficult to solve a quadratic equation using completing the square sometimes. So the quadratic formula, which you're going to see in a minute, as it says in this last sentence, can be used to solve any quadratic equation. So you do have to be very careful when you read your assignments. There are certain questions that are going to ask you to solve by factoring or solve by completing the square or solving by square roots or solving by using the quadratic formula. And if the question asks you to use a specific method, I will be looking for you using that specific method. However, if the question just says solve the equation, you are allowed to pick whichever method you want. And even if factoring might be a little bit easier in certain situations, or completing the square might be easier in other situations, the quadratic formula will work every single time. As long as you know the formula and you have it in your back pocket, you can use it whenever you want to solve any quadratic equation. So, what is the quadratic formula? It's this huge mess. Okay? This one, the, I guess, quote unquote, standard form that you want your quadratic equation to be in before you use the quadratic formula, is kind of like how we did with factoring, where we want everything to be over to one side, over to the left, and then we have equals 0 on the right. So if you have that set up, then you can use all of the coefficients, your a value, your b value, and your c value, to then plug into this giant quadratic formula mess. Negative b plus or minus, that comes back, the square root of b squared minus 4ac all over 2a. Some of you guys might have seen this before. I think there are like some YouTube videos out there about like songs and little jingles to remember the quadratic formula or to help you remember the quadratic formula. But definitely, I hope you guys are still taking really, really good notes as you're watching these videos. I hope you're even watching this in the first place. But I do hope you guys are still taking good notes, and I would definitely put this in your notebook with a big, big star next to it. All right? I'm even going to do that. Yeah, there we go. Okay? Because this is really important. And this is probably going to follow you for the rest of your math student careers. So, we're just going to practice using the quadratic formula. All right? You saw earlier, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, I hope you noticed this earlier. What number corresponds with which variable? It's from this quadratic trinomial right here. This coefficient, we have the invisible one right here. So the coefficient of x squared is your a value, the coefficient of x is your b value, and the coefficient, the constant at the very end is your c value. It goes in alphabetical order, a, b, c. So it helps a lot of people to actually list all those values out before you even start. So you're going to see me doing this on the answer key to your homework. A equals 1. You do have to remember your signs, though. B equals negative 9. And C equals positive 20. All right? And then all of this goes in here. So negative 9, which we can do right away as positive 9, plus or minus the square root of negative 9 squared, careful with your parentheses, minus 4 times 1 times 20. All over 2a, so 2 times 1. And then the only hard part is really just simplifying all of it, all right? We know what 2 times 1 is. That's 2. We're not doing anything with the 9 yet because we want to simplify this huge mess inside the radical, all right? So it does go with the order of operations, all right? If we're simplifying an entire expression underneath a radical, the order of operations still applies. So PEMDAS, parentheses, exponents, multiplication and division, and then addition and subtraction. So the exponents, negative 9 squared, I say be careful with your parentheses because you should know negative 9 times negative 9 is positive 81. All right, even if you plugged it in your calculator. And then we can multiply all three of these things at once. Negative 4 times 1 is negative 4, and negative 4 times 20 is negative 80. So this is 81 minus 80. All right? Then we can finish off with the subtraction. 81 minus 80 is 1. So this is 9 plus or minus the square root of 1 over 2. We got lucky that 1 is a perfect square. The square root of 1 is 1, so I'm going to move up over here. So this is 9 plus or minus 1 over 2. All right, and it looks a little weird, but because we have all whole numbers, we are able to kind of do a similar sort of thing that we did with solving by square roots and split these up into two separate, not really equations this time, expressions, and simplify. Again, not solving. So we're going to do 9 plus 1 over 2 over here. 9 plus 1 is 10 over 2 is 5. So one of your solutions is 5. And then we're going to do 9 minus 1 over 2. 9 minus 1 is 8 over 2 is 4. So your other solution is 4. We're still talking about solving quadratic equations, so you should still get maximum 2 answers whenever you do these problems. There is a possibility that you can get one answer only. There is a possibility that you can wind up with no solution. All right? And all it said was show your work. It didn't ask us to check our answer. If you did want to check your answer, same thing as always. You would plug each of these x values back into the original, one at a time. It should get you 0 back out. All right? And if it doesn't, you probably did something wrong. Okay. So, from the beginning, we want every single term over to one side, preferably the left side, or kind of the same thing when we did solving by factoring, so that the squared term is positive. So it's positive when it's on the left, so we're going to move everything over to the left. What that means is we're going to subtract x and subtract 20. Cancels out from the right, but none of these are like terms. Okay? So we're just going to leave them all in a line. Equals 0, because everything else canceled out on the left. I mean on the right. Okay? So then it looks exactly like the problem that we did before. Okay? We're going to use the quadratic formula, but again, if it helps you to write down specifically what A, B, and C are before you do anything, go for it. A is 1, B is negative 1, and C is negative 20. Again, be careful with your signs. All right? So, let's go over here. Negative B. Let me write down the quadratic formula. There's your quadratic formula. So negative B. Negative 1 is positive 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 20. All over 2 times 1. Okay. So 1 plus or minus the square root of negative 1 squared is 1. Negative 4 times 1 is negative 4 times negative 20 is again 80. But because we have the negative times a negative, this is positive 80. All over 2 times 1, which is 2. You can kind of like, because of the order of operations, you can kind of do a bunch of little steps kind of at once. That's what I'm doing here. I simplified this, and I simplified this all at once. All right. If you need to really, really break it down and do one single step at a time, that's absolutely fine. Okay. But then we can do 1 plus 80. I'm just going to do only that one step. 1 plus or minus, so then it's the square root of 81 over 2. All right. I'm going to move down here. 81 also happens to be a perfect square. It's 9. So 1 plus or minus, no, wait, we don't need that square root. 1 plus or minus 9 over 2. Okay? So this is the same thing as last time then. We can break this up. 1 plus 9 over 2 is 10 over 2, which is again 5. So that's one answer. And then 1 minus 9 over 2 is negative 8 over 2, which is negative 4. And those are your two answers. Okay? And I'm going to do this one too, just because I think that some weird things are going to happen. All right? So let's see. A is 1, B is 3, and C is negative 7. So if this is the quadratic formula, we're just going to plug everything in again, all right? So negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 7, all over 2 times 1. So negative 3 plus or minus, and then we're going to go in with all the simplifying. 3 squared is 9. Negative 4 times 1 is negative 4 times negative 7 is positive 28. So this is 9 plus 28 over 2 times 1 is 2. I'm just going to move up here for more space. 28 plus 9 is 37. So this is negative 3 plus or minus the square root of 37 over 2. All right. 37 is not a perfect square. Okay? But I think I said this last time, we always have to try to simplify radicals whenever we can. All right, so I'm going to bring back that perfect squares sheet. 37 is going to go right here. And honestly, I doubt that 37 is actually going to simplify. But if we just go through the motions, no. Yep. There's no factors of 37 that are perfect squares. All right. So we're going to have to leave this as the square root of 37. So it doesn't simplify with the 2 on the bottom. Neither does the 3. I think we're going to get a chance to talk about that in a couple minutes. But there's unfortunately really nothing else you can do with this number. All right. So it is a number, you know, if you plugged negative 3 plus square root of 37 over 2 in your calculator and negative 3 minus the square root of 37 over 2, you're going to get two separate numbers, all right? But it's the same sort of thing as, excuse me, same sort of thing as when we were doing all the square root business. We don't want decimals, all right? Even though it looks really weird, in the math world, this is much more of a pretty answer than a really long, ugly, or even a rounded off decimal, all right? And because you wouldn't be able to do anything with the negative 3 plus square root of 37, you wouldn't be able to combine any like terms there, leaving the plus minus is, you know, a little bit better, all right? So I boxed that off because, again, there's nothing we can do with it, and that is actually going to be our final answer for this problem, all right? Let's do it. All right. A is 6. B is 5, and C is negative 4. So, all right. So negative 5 plus or minus the square root of 5 squared minus 4 times 6 times negative 4, all over 2 times 6. Negative 5 plus or minus the square root of 25. Negative 4 times 6 is negative 24 times negative 4 is 96. There we go. So this is 25 plus 96 over 2 times 6, which is 12. All right. Negative 5 plus or minus the square root of... Oh, okay, cool. 121 over 12. 121 is actually a perfect square, in case you guys forgot. The square root of 121 is 11. So this is negative 5 plus or minus 11 over 12. And now it kind of looks like what we did earlier. All right, we can break it up and simplify them separately. So negative 5 plus 11 over 12 is 6 over 12. And it doesn't divide evenly, but you can reduce the fraction. And same kind of thing with, we want to try to avoid decimals, so we're actually going to leave this as a simplified fraction. 6 and 12 are both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So 6 over 12 simplifies to 1/2. That's one of your answers. Negative 5 minus 11 over 12 is negative 16 over 12. Those are both divisible by 4. So negative 16 divided by 4 is negative 4. And 12 divided by 4 is 3. So this simplifies to negative 4 over 3. And that is your other final answer. Okay? Okay. All right. Last problem like this. I hope you guys are pretty used to how this works by now. But let's see if anything interesting happens. So, same thing. A is negative 3, B is 5, and C is 2. So there's a formula. So negative 5 plus or minus the square root of 5 squared minus 4 times negative 3 times 2. Oops. I already wrote 2. Okay. All over 2 times 3. All right. So negative 5 plus or minus the square root of 25. Negative 4 times negative 3 is 12, times 2 is 24. So this is plus 24 all over 2 times 3, which is 6. Okay. So this is negative 5 plus or minus, I think 49. Yeah, 49. Oh, wait, this is negative 3. This is negative 6. This is negative 6. There we go. Okay. But beyond that, the rest of this problem is exactly the same. 49 is another perfect square. It's 7. So this is negative 5 plus or minus 7 over negative 6. And then it's exactly the same thing as the last one. You split it up. All right. Negative 5 plus 7 over negative 6 is 2 over negative 6. They're both divisible by 2. So this is negative 1 over 3. And then negative 5 minus 7 over negative 6 is negative 12 over negative 6. And that divides nice and evenly. It's 2. All right. So the only things that I don't think showed up in this specific slide deck are, well, we didn't see any no solution problems. All right. But we actually are going to talk about that once we talk about the discriminant. And the only thing I do want to say is, let's say you were able to simplify a radical. Like if I go back to this problem, for example, And I'm just going to make up a couple numbers. Like, I'm just going to flip this over. It has nothing to do with the problem that I just showed you. But let's say instead it said -3 plus or minus. Like, we were able to simplify that radical. And it said 2 root 37 over 2. All right? When you're simplifying fractions like this, you do have to be very, very careful. I don't know if you guys remember, like, the butterfly method from, like, the way beginning of the school year. If you're simplifying, or if you're dividing an entire expression by a number, every single piece of the expression has to be divisible by whatever number you're dividing by in order to reduce it. So that means you not only have to be able to divide 2 by 2, but you would have to be able to divide -3 by 2 as well. 2 divided by 2 works out nicely, but -3 divided by 2 doesn't. So in that situation, this is another type of problem that you would have to leave as is and be done with it. If I changed around the numbers again and said -4 plus or minus 2 root 37 over 2, you can't, I didn't say this, but you can't do anything with the 37 because it's underneath a radical and everything else isn't. But if we use that butterfly method again, this works out nicely because -4 is divisible by 2 and 2 is divisible by 2 as well. So you would be able to simplify this expression. -4 divided by 2 is -2 plus or minus 2 divided by 2 is 1 times the square root of 37. And you don't even need that one. It's like the same thing as saying 1x. 1 times x is x. 1 times the square root of 37 is the square root of 37. So you could even simplify this further to say -2 plus or minus just the square root of 37. All right. I just wanted to talk about that really quick in regards to simplifying because I do think you are going to see problems like that on your assignment on this. And now let's move on to the discriminant. The discriminant I do think is, well, I know it's a lot less work, and I think it's a lot more straightforward. So, again, before we even worry about anything involving the discriminant, it has to be in standard form, which means every single term over to the left and you have equals 0 on the right. But the difference between the actual quadratic formula and just the discriminant is the only thing the discriminant tells you is how many solutions there are to that equation. Not necessarily what the solutions are, just how many. All right. Again, your options are only 2 solutions, 1 solution, or no solution. All right. And it really just is based on the signs. All right. And that is a little technical, right? But if you have something greater than 0, that means it's a positive number. All right. So if the discriminant gets you a positive number, the equation has 2 real solutions. So if you get a positive number, your final answer to the problem is 2 solutions. If it equals 0, you have 1 real solution. And then if it's less than 0, if it's negative, you have no solution. All right, so I want to talk about why that is while we're here. Because I'm going to go back to the quadratic formula. All right, this is the only piece. This is the discriminant, all right? I don't know if I actually said that. B squared minus 4AC. And if when you plug in all your numbers, you get one of these 3 things, that tells you how many solutions there are. But if I go back to the quadratic formula, if this is the discriminant itself is actually coming from the piece of the quadratic formula that's completely under the square root, all right? So let's, throw out some numbers. I think the last one we did was we did the square root of 49. So if you were actually evaluating the square root of 49, you have to be careful with your plus minus. So the square root of 49 could be positive 7 or negative 7. That's 2 solutions, which matches up with what the discriminant says. What if you get 0 underneath the radical? If you take the square root of 0, well, what's the square root of 0? It's 0, and 0 is neither positive nor negative. You can't do plus minus 0. It doesn't make any sense. So you only get 1 solution when you're taking the square root of 0, which is what the discriminant is also saying. And if you have a negative number underneath the radical, like let's say it was negative 49, we saw when we first started talking about all of this that you can't take the square root of a negative number. If I pulled out my calculator again and did the square root of negative 49, I get that because taking the square root of a negative number is impossible. So there is no way to simplify this. If this was your problem, your answer would be no solution, which again matches up with what the discriminant says. All right, so that's a little explanation of why it is the way it is. And that's the difference between the discriminant and actually solving the equation. So again, you have to be really, really careful with what the directions say for these kinds of problems. All right. So the nice thing here is that we've got all three of these in standard form. You don't have to move anything around. And I'm just going to kind of squeeze the discriminant right here for our reference. So it's still the same idea as before. A is 3, B is negative 2, and C is 2. But this is that's what we're plugging all these numbers in. Not the giant quadratic formula mess, because it just says find the number of solutions of each equation using the discriminant. So, negative 2 squared minus 4 times 3 times 2. What does that get us? Negative 2 squared is 4. Negative 4 times 3 is negative 12. Times 2 is negative 24. So 4 minus 24 is negative 20. The number itself doesn't really matter too much, all right? What matters more so is the sign, all right? Because we got negative 20, we got a negative number. How many solutions are there? No solutions, or no real solutions, all right? There are such things as imaginary numbers, but we don't talk about them in Algebra 1. You'll probably see them in a couple years when you take Algebra 2. Okay. So that is your final answer. Because you get a negative number for the discriminant, there are no real solutions. I didn't even say what I wanted to say. I'm fine if you just say no solutions. You don't have to say no real solution. But if you want to go that extra mile, go for it. All right, part B. A is 2, B is 11, and C is 12. So, yeah. 11 squared minus 4 times 2 times 12. Okay? 11 squared is 121. Negative 4 times 2 is negative 8 times 12 is negative 96. So this is 121 minus 96, which is probably going to get us a positive number. Yeah, it gets us 25. And again, the number itself doesn't matter. What matters is the fact that we got positive 25. So that means there are two real solutions, or two solutions. Okay? And here, A is 1, B is 8, and C is 16. So 8 squared minus 4 times 1 times 16. 8 squared is 64. Negative 4 times 1 is negative 4 times 16 is negative 64. So that gets us 0, and there's the example of the one solution idea. Okay? All right. I think, yeah, this is another, like, the exact same thing that we just did. And because we're approaching the half-hour mark, I'm going to do this off camera and upload it with the digital copy of these answers that you guys get anyway. And that's actually it. That's the end of it. So that's the end of solving quadratic equations. We've covered every single method. All right. So there is going to be an assignment on this. Please check on that. As always, there are plenty of resources for you guys to reach out if you have any questions. And I think that's everything I got for you for today. Stay safe. Talk to you guys soon.